For decades, we've been staring up at the stars, listening, and all we've heard is silence. But what if that silence isn't telling us we're alone? What if it's telling us we've been looking at the universe all wrong? This is the story of that cosmic silence, and honestly, it might just change everything you think you know.
It all boils down to this one simple but profound question, first asked by the physicist Enrico Fermi way back in 1950. It's a question that still haunts us today. Given everything we know, where is everybody?
And this really puts the scale of the problem into perspective. On one side, you have the potential, a galaxy with hundreds of billions of stars, countless planets, and billions of years for life to emerge. I mean, the numbers alone suggest the cosmos should be absolutely buzzing with civilizations. But on the other side, that's our reality, a deep, profound, and kinda unnerving cosmic silence.
Now, it's really important to get this next point. This isn't just a lack of evidence. No. This is an evidence-based silence. It's a real conclusion we've drawn from decades of actively, and I mean rigorously, searching.
And believe me, it's not for a lack of trying. We have looked everywhere. We've used massive radio telescopes to listen for signals. We've used optical telescopes trying to spot enormous alien megastructures, things like Dyson spheres. We've even used infrared telescopes to look for the waste heat a giant civilization would have to be giving off. And across the entire spectrum, every single time, the answer has been the same: nothing.
So, okay, if they're not out there, then maybe they just can't get here. And that brings us to the first huge potential reason for the silence: the cold, hard, unbending laws of physics.
And wow, this slide just lays out the brutal reality of trying to travel between stars if you're, a living, breathing creature. We're not talking about journeys of years. We're talking hundreds of thousands of years. The radiation out there is lethal. Trying to keep an ecosystem stable on a ship for generations, we can barely do that here on Earth. And with communication delays of millennia, you're completely cut off. The galaxy, for fragile biology, is just too big. It's a non-starter.
But what if we're thinking about the wrong kind of traveler? What if the emissary isn't biological at all? The most logical alternative isn't a creature, it's a machine. So, if biology is just too delicate for this kind of journey, what's the logical next step? It has to be artificial intelligence. I mean, look at the comparison here. An AI probe solves every single problem. It's tough, it can handle radiation, its lifespan is, for all intents and purposes, infinite. It could even be a self-replicating machine, what's called a von Neumann probe, using asteroids to build copies of itself. And this is key, it could be designed for stealth, its communications hidden to look just like the normal background hiss of space.
So AI probes seem like the perfect answer, right? Well, this is where our story takes a major turn. Because even for a perfect, immortal AI explorer, there appears to be one final absolute wall it just can't break through. The speed of light. It's the ultimate cosmic speed limit. Based on everything we know and everything we've seen, nothing with mass can get there, let alone go faster. So even for a machine that lives forever, filling the galaxy is a project that takes millions upon millions of years. It really seems to be the ultimate barrier. Unless the very map we're using, our fundamental understanding of the universe, is just wrong. And here's the kicker. Our map is showing cracks. Big ones. Recent data from our absolute best instruments is showing these major tensions that our current model of the universe just can't explain. First, you've got the Hubble tension. Basically, different ways of measuring how fast the universe is expanding are giving us different answers. And the disagreement is now at what's called a 5 sigma level, which in physics means it's for sure not a fluke. Then you have the James Webb Telescope finding these so-called impossible galaxies that are way too developed for how early they exist. And finally, the DESI survey is hinting that dark energy, the very force pushing the cosmos apart, might be changing over time. These aren't small issues. These are signs that our whole rulebook might be incomplete. All of this leads us to a really mind-bending, radical idea. Maybe the problem isn't out there in deep space. Maybe the problem is right here with us in the assumptions we use to look at the stars. This slide gets to the absolute heart of it. We don't actually see the universe as it is. We see it through the lens of our models. Think about it. We get this raw, pure data. Light, frequency, stuff our sensors actually see. But then we run it through this prism of assumptions, ideas about expansion and dark matter that are a century old. What comes out the other side are these cooked results, things like distance and age. They're not direct measurements, they're interpretations. The cracks we're seeing,
That's our model itself starting to break under the pressure of new, more accurate data.
So what's the solution? Well, it's a completely new way of doing science, a model-free protocol. And it's brilliant in its simplicity. Step 1, you strip away all those assumptions, all those inferred ideas like distance or age. Step 2, you uncook the data, taking it all the way back to the raw, pure numbers the sensor actually recorded. And then step 3, you unleash unbiased AI on that raw data to find the true, fundamental patterns, the mathematical rules that are really there. Those rules become the foundation for any new theory of the universe.
Okay, so that's a whole new way to do science. But how does this new way of seeing the cosmos actually solve the mystery we started with? How does it explain the cosmic silence?
And this is where it all comes together beautifully. By looking at the raw, unbiased data, we could discover totally new physics that our old models were hiding from us. That new physics might reveal things we can't even imagine now, maybe shortcuts through spacetime that let advanced AI probes completely bypass that light speed barrier. So the cosmic silence, it's not because they aren't out there. It's a reflection of our own model-dependent blindness. We haven't been able to see them.
And the best part is, this isn't just some cool theory. It's a concrete, actionable plan. A 24-month sprint to build the world's very first open, uncucked, model-free repository for cosmological data. This creates a level playing field, a neutral ground where any theory, from our current model to the most out-there new ideas, can be tested against pure, unadulterated data. It's about letting the universe tell us its secrets instead of us telling it what it should be.
So, where is everybody? Perhaps they've been waiting for us this whole time, waiting for us to finally take off our blinders, strip away our old assumptions, and learn to see the cosmos not as we imagine it to be, but as it truly is.